Right then, let's talk about power, or, more specifically, why we always seem to want more of it. You could be driving a perfectly sensible family hatchback, something designed to be good at taking the kids to school and doing the weekly shop. It's fine, it gets the job done. But then you find yourself on a slip road, trying to merge with fast-moving traffic, and you put your foot down. The engine groans a bit, it thinks about it, and then eventually, it starts to pick up speed. In that moment, you can't help but think, oh, I wish this thing had a bit more oomph. It's a universal feeling, that desire for a little extra shove in the back when you ask for it. This isn't just about being a speed demon or wanting to race everyone away from the traffic lights, although that can be fun. It's about confidence. It's about knowing that when you need to overtake a slow-moving lorry on a country lane, your car has the grunt to get the job done quickly and safely. Power gives you options. For decades, the simple answer to getting more power was just to build a bigger engine. If you wanted more go, you needed more cylinders, more displacement, a great big V8 lump of American muscle. But that meant more weight, more fuel, and, well, less space for your shopping. It was a brute force solution, and a rather thirsty one at that. But what if there was a cleverer way? What if you could get the power of a big engine from a much smaller, lighter one? Imagine having all the get up and go you could ever want, but without the terrible fuel bills and the planet-sized engine block under the bonnet. This is the puzzle that car engineers have been trying to solve for years. How do you conjure up power out of thin air, without the traditional downsides? This quest for clever power, for efficient performance, is what led to one of the most brilliant and transformative bits of engineering to ever be bolted to an engine. It's a little device that completely changed the game for good. This is where the magic really begins. The solution they came up with is ingenious. A masterpiece of recycling that takes something the engine is throwing away anyway and turns it into pure, unadulterated acceleration. It's a bit like finding a winning lottery ticket in a bin. You're taking useless waste and transforming it into something fantastic. This brilliant idea has allowed car makers to give us cars that are not only faster and more exciting to drive, but also surprisingly good on fuel. It's the reason your sensible modern car can feel so surprisingly lively, and it's all thanks to a wonderful piece of kit we call the Turbocharger. So, what exactly is this miracle device? Let's get to it. A turbocharger, or turbo for short, is basically a very clever air pump. If you pop the bonnet of a modern car, you'll often see it nestled near the engine, looking a bit like a metal snail shell. It's a compact and intricate piece of machinery, but its job is wonderfully simple in concept: to force more air into the engine's cylinders than it could normally suck in on its own. It's not powered by belts or chains from the engine itself. Instead, it uses a form of energy that would otherwise be completely wasted, which is what makes it so brilliant. Inside that snail-shaped housing, there are two key parts: a pair of small fans or wheels called a turbine and a compressor. These two wheels are connected by a central shaft, so whenever one of them spins, the other one spins at the exact same speed. Think of it like two pinwheels stuck on either end of a knitting needle. They are separate but linked, destined to spin together in perfect harmony. One of these fans sits in the path of the hot exhaust gases leaving the engine, and the other sits in the path of the clean, fresh air heading into the engine. This clever placement is the absolute key to how the whole system works. Now let's talk about where this thing lives. The turbo is bolted directly onto the engine's exhaust manifold. This is the pipework that collects all the hot, high-pressure waste gases from the engine's cylinders after the fuel has been burned. Normally, these gases would just flow straight down the exhaust pipe and out the back of the car, their energy completely wasted, making a bit of noise on the way. But with a turbo, these gases are put to work. They are channeled directly into the turbine side of the turbocharger, which is the hot side of our mechanical snail. This strategic location means the turbocharger is perfectly positioned to intercept the engine's waste stream. It's like putting a water wheel in the middle of a fast-flowing river. The river was going to flow anyway, but now its energy is being harnessed to do something useful. By capturing the force of these escaping gases, the turbo gets a free ride, spinning up to incredible speeds without stealing any direct power from the engine's crankshaft. This is fundamentally different from another device called a supercharger, which is driven by a belt and does sap a little bit of the engine's power to work. The turbo is the ultimate recycler. Here's how the magic trick unfolds, step by step. When you press the accelerator, your engine starts burning fuel and creating exhaust gas. These hot, high-pressure gases rush out of the cylinders, and instead of just going out the tailpipe, they are forced to flow over the blades of the turbine fan inside the turbo. This powerful jet of gas spins the turbine wheel at mind-boggling speeds. We're talking up to 250,000 revolutions per minute. That's more than 4,000 spins every single second. It's almost impossible to imagine something spinning that fast without just flying apart, which is why they are made from incredibly strong and exotic materials. Because the turbine is connected to the compressor wheel by that shaft, the compressor starts spinning at the same insane speed. The compressor wheel is on the cold side of the turbo, and its job is to suck in fresh air from the outside through the car's air filter. As it spins, it acts like a powerful jet engine in miniature, grabbing huge gulps of air and compressing them. This means it squeezes the air, packing the molecules closer together and increasing its pressure. The result is a dense, oxygen-rich charge of air that is now ready to be forced into the engine, a process we call boost. Now think about blowing on a campfire to make the flames bigger. When you blow gently, you add a little bit of air, and the fire grows a bit. But if you use a big set of bellows, you can force a huge amount of air into the fire all at once, and it will roar into life, burning much hotter and brighter. The turbocharger is like a massive, industrial-strength set of bellows for your engine. An engine is, at its heart, just a device that burns a mixture of air and fuel. By forcing more air in, the turbo allows the engine to burn a proportionately larger amount of fuel in each cylinder. This combination of more air and more fuel in the same amount of space creates a much bigger, more powerful explosion during the combustion stroke. It's this more potent bang that pushes the piston down with much greater force. More force on the piston means more torque, which is the twisting force that ultimately turns the wheels and pushes the car forward. So you see, the turbo doesn't create power out of thin air. It simply enables the engine to burn more fuel more effectively, unlocking the potential for a much bigger bang from a smaller engine, all by cleverly recycling energy that was going to be thrown away. So, why are these things everywhere today? Simple. Turbochargers offer the perfect solution to a modern problem. We all want cars that are powerful and fun to drive, but we also face stricter emissions regulations and want better fuel economy to save money at the pumps. The turbo allows car makers to have their cake and eat it too. They can use a smaller, lighter engine, say a 1-liter 3-cylinder, which is naturally very fuel efficient when you're just pottering around town. But when you put your foot down, the turbo spools up and gives you the power you'd normally expect from a much larger 1.6 or 1.8-liter engine. It's the best of both worlds. The primary benefit, as we've seen, is this fantastic blend of power and efficiency. A turbocharged engine can produce the same amount of power as a larger, non-turbocharged or naturally aspirated engine, while burning less fuel and producing fewer CO2 emissions. This is why you see EcoBoost, TSI, and other turbo-branded engines in everything from tiny city cars to massive SUVs. It's an engineering win-win. Another great benefit is performance at high altitudes. As you go up a mountain, the air gets thinner, and non-turbo engines struggle and lose power. A turbo, however, just compensates by spinning faster to cram enough air in, so performance stays strong. Of course, it's not all sunshine and rainbows. There are a couple of things to be aware of. The most famous is turbo lag. This is the short delay you sometimes feel between planting your foot on the accelerator and the turbo delivering its full punch of power. This happens because the exhaust gases need a moment to build up enough pressure to spin the heavy turbine and compressor wheels up to their effective speed. Engineers have become very good at minimizing this lag with clever designs like twin-scroll turbos and variable geometry, but you can sometimes still feel a slight hesitation in older or more basic designs. Furthermore, because turbos spin so incredibly fast and get extremely hot from the exhaust gases, they need a constant supply of clean, high-quality engine oil to lubricate and cool their bearings. This makes regular oil changes even more critical for a turbocharged engine than for a naturally aspirated one. Neglecting oil maintenance can lead to a very sad and very expensive turbo failure, but these are small considerations for the immense benefits they provide. The turbocharger has fundamentally reshaped the modern car, allowing us to drive vehicles that are cleaner, more efficient, and most importantly, a whole lot more fun. They are, without a doubt, a masterpiece of engineering.